Hello dear students, today I am starting chapter 8, application of integrals. Very simple chapter. Okay, my topic is very simple because we have already studied about integrations. How can we solve any type of integrations? Here very simple integrations are required to solve for finding area. Application of integrals completely depends. Here, the finding the value of integral, but before finding the value of integral, we must understand what is the area, what is the portion of a plane area. But area enclosed by some lines, curves. Our first topic is area under simple curves. Here, we have to study about area under simple curves. Simple curves means straight line, circle, parabola, ellipse. These are the simple curves. We know from 11th class. You can draw circle of equation, ellipse, also line. How can we draw a line? Identify two points and by connecting them, we can draw a line. We can also draw parabola, open curve, ellipse, circle, closed curve. These are required for finding area under simple curves. Okay, area under simple curves is very simple. Formula is just like at the time of when we define fundamental theorem of integral calculus of first fundamental theorem, that is area function. So this is area function. This is area function. Also we know this definite integral can be defined as a limit of sum. As a limit of sum. Limit of sum means what? Limit of sum of area of rectangles. Sum of area of rectangles. Area of rectangles. Xi, delta xi, breadth, length of a rectangle. And sum of how many rectangles are there. We are making rectangles by vertical lines. This I equals to 1 to n. And limit n tending to infinity. This is the limit of sum of areas. Also this definite integral. Area function. Okay. Here just we will require drawing of line, circle, parabola, ellipse, very urgent. So just revise this topic. How can you draw line? How can you draw a straight line? Parabola, ellipse, circle. Okay. So area under the curve. Area under simple curves means, suppose this is curve. Curve means what? Relation between x and y. Simple curve means there will be simple relation. Suppose y equals to fx. Generally we are denoted like this function y equal to fx. Relation between x and y. There will be frame. Frame means x-axis and y-axis. X-axis and y-axis. Origin, this is negative side, x dash, this is y, this is x, this is y dash. So suppose y equal to fx is a curve. Curve may be of infinite length, but area under simple curves means, suppose this is curve, area under this curve, area maybe this. So area bounded by what? Area bounded by curve, this line, and also the value of x vary from this along this line. So suppose here x equals to a, here x equals to a point, x equals a is a point, 2x equals to b, 2x equals to b. Clear? So this line, this is the value what? Fa. For x equal to a, y equals to fa. This is fa, this point. What? This point will be a xy, a fa, a fa. Similarly, x equals to b, this is x equals to b and f b. This is this point. Suppose this is a, this is b, this is c, this is d, our point. So now this area under the curve under area, x-axis, curve, x equal to a, x equal to b, ordinate, x equal to a, x equal to b. This area we can find by our logic in such a way that if we, because there are curve, one side is curvature, so we cannot treat it as a rectangle. But if we draw vertical line and from here to here, just how many vertical lines? As maybe, so n vertical lines, then there will be n rectangles, the sum of area of that rectangle. When we make rectangle, then we can think that the width of rectangle is tending to 0, that is curvature is tending to 0. Then our formula for finding area of rectangle, length into breadth, may be used. That's why n tending to infinity means if number of rectangles n tending to infinity means width tending to 0. So then we can get equivalent result. So in the limiting form, we are using limit. Here, so suppose there is a general rectangle. There is a general rectangle. Its width is, suppose delta x. Very simple, very small delta x, width of this rectangle. By drawing vertical line, we can get n rectangles. So this is one of the rectangles. Delta x width, and this value is what? At this point, y. Suppose this is y. Clear? This y can we get from here. Value of y in terms of x can we get from. So this is steep. We can say this is steep. So its area y, length into breadth, y dx. Y dx. Length into breadth. Delta x. Delta x, single quantity. Okay. Length into breadth, this area. So elementary area. Elementary area. Elementary area. Area of elementary strip. Clear? When we apply limit to this, then we get area. Elementary area dA equals to y dx. When we apply limit, then delta tending to d, delta y delta x, y dx. This is elementary area, just like derivative dx. Okay. When this is elementary area for this. Now we require whole area. So we can vary the value of x from a to b and sum of all. So that is integration of y dx from a to b. This is limit of x. This is area. What? A, B, C, D. A, B, C, D. Area is. Okay. Integration y dx. Well, a to b. X vary from a to b. This is the area. Area. Okay. Y means from the equation of the curve. Maybe it also, we can suppose this is linear curve, means line. Then also from there we can find y equals to in terms of x. And then for curve, suppose y equal to x square. Then the value of y is x square, curve, parabola. Y plus x equals to 5. Then y equals to what? 5 minus x. The value of y is 5 minus x. This value will be used here and limit from a to b. We apply and then we can solve it, integration. That will be the area. Okay. So finding area, very simple. This is the first formula. Okay. Similarly, if curve lies in the below the x-axis, that is curve lie like this. Suppose then area, if we find the area by using this rule, then we will get negative sign. But we take only numerical value. That's why if there are two types of area, then we can take absolute value. Just like this. Suppose this is x-axis, y-axis and x-axis. Okay, this. If suppose one curve is like this, so this part is on upper part, on the upper side, this is in the lower side. So A, B, C, D, E, this area is positive. Suppose this is area A1 or this is area A2. Finding method is same. From here x equals to suppose A, here x equals to suppose B, here x equals to suppose C. Then area of this area, how can you find? Suppose this is the curve, this is the curve. Curve also lies because curve may be infinitely go to here and there. So suppose here to this like this, then this is upper part, this is lower part, this area will be negative. So total area, this plus this, total area equals to A1 plus A2. But A2 is in the lower part, so you have to take modulus value, numerical value. Because this will give negative value, so we will get negative value. So we must take the numerical value, that is by taking modulus of them. Clear? And this is area under the curve, means curve, x-axis and ordinate to ordinate. If we have equation like this type of diagram, suppose this is curve and this can be written as x equals to function of y, and also relation between x and y. So this is line y equals to c, this is line y equals to d. Then this part area under the curve. This is y-axis, y-axis. This is x-axis, origin. Okay. So here x equals to fy. This is the curve. Now here we take horizontal strip. We take horizontal strip. Horizontal means like this, parallel to x-axis. Vertical strip means parallel to y-axis. Strip is this. Okay. Suppose this is strip. Now here length of this simple small value delta y, or this is this value along x-axis. This is x. So its elementary area what will be? Delta x. Okay. So the dA equals to what? X dy. So area of this can we get by using what? X dy. Here y dx, here x dy. And limit of y vary from C to D. So C to D. This is area of P, L, M, and O. P, Q, R. Okay. So L, M, N, R. L, M, N, R. This area made finding by this formula. So our formula is what? It's nothing. Y dx and x dy. Where y comes from the value of y from the curve. Value of y in terms of x. Here x dy, value of x in terms of y. Here limit a to b means value of x. Here limit c to d, value of y from c to d. These two types of area. This is x dy means this type of area, and y dx means area under area between this four quantity. What are y axis curve, this. Similarly, if area like this, then curve this gives y dx. Okay, a simple formula. And that is what we take area of elementary stream. Okay, suppose we are having diagram just like this. Upper part is a line and lower part as a curve. Suppose we are having diagram like this. Now we want to find this area. So how can we get the area of this area? This is x-axis, this is y-axis. Okay, y-axis, x-axis, x dash, y dash, origin. This is curve A, B, C, D. ADC, this is line. ABC, this is curve. Now we want to find area of this part. So here, first of all, this is closed diagram. So corner points means intersected point. You have to find first of all coordinate of intersected point. How can we get value of coordinate of this corner point? Solve this and this intersection point of these two, curve and line. Clear? You can get here coordinate, here coordinate. If x equals to suppose a1, b1, xy. So this is x equals to a1. If here a to b2, suppose a to b2, that is we draw perpendicular. parallel line, your x equals to what? A2. This is B1, this is B2. Now, for finding area, this area, we can take either horizontal strip or vertical strip. Suppose vertical strip means what? Draw vertical strip. Draw line parallel to y-axis. Horizontal means parallel to x-axis. So we can take like this strip parallel to y-axis. This is a strip. Its length vertical, length along y. So here, for finding the length of this, for this curve, this is the value of y. For this curve, this is the value of y. From here to here, for this curve, this is the value of y. For this curve, this is the value of y. So for this length, we can get, suppose this is line, this is curve. This is a line, this is curve. Clear? So for finding this length, width, we can consider delta x along this axis. So, and for length of this, how can we find the length of this? Value of this. Suppose this is A, B, C, D, E. ED. ED gives the value of y for line, upper curve. Y from line minus this. And suppose this is F. Here, this. Y from curve. Curve, this is the point on curve. So y from curve. Y from curve. Value of y from line upper minus value of y from lower curve. That is y from upper curve, maybe line curve, maybe anything. Y from lower curve. This is the length of this. So, suppose upper y1, lower y2, then this upper lower. This is the length of this strip into delta x, This is elementary area of this strip. So area between this line and this curve, in place of y dx, we have to take y1 minus y2 dx. That is integration of this a to b. Similarly, if this diagram take along horizontally, then we can get x1 minus x2 dy and c to d. This area. So area between these two curves. Actually, area between these two curves. So for finding this, y from upper curve minus y from lower curve, we put here and then dx, then integration with respect to x. And if this type of formula you used, then limit of, that is the value of y from c to d. So these are two formula, okay? Area between two curves and area under the curve. So very simple formula are there. Only how many formula? 2, 3, 4 formula. Okay. So these formula are used for finding area between curve and also area under the curve for simple curves. Okay, we are using simple curve. So first formula is what? Y dx. Second is what? Y dy. What? Y1 minus y2 dx. Third, what? X2 minus x1 minus x2 dy. These are the formula for finding area. Clear? So first area equals to area equals to area equals to. We know about meaning of how can find area. This is A to B. This is C to D. A to B. C to D. Area between two curves. Area under the curve. This along vertical strip, horizontal strip, vertical strip, horizontal strip. These are the formula. Now we will solve exercise questions from exercise 8.1. Okay. For solving questions related to area, we must know how can we draw the diagram, a straight line, ellipse, parabola, circle. Okay. So revise this portion from your 11th class. Very urgent for this, finding this area, because sometimes in the exam long questions are asked from this chapter. Okay, so just revise how can you draw diagram for parabola, ellipse, circle and line. Okay. Now take questions from exercise 8.1. The first question is, find the area of the region bounded by the curve y square equals to x and line x equals to 1, x equals to 4 and x axis is the first quadrant. Y square equals to x. So solution, question 1 from exercise 8.1. Okay. So here given, first of all identify boundary of the region. So y square equal to x, curve. So we have to draw diagram first of all. Then we can understand what will be the formula. Okay. This is x axis, y axis and origin. How many curves are there? X equal to 1, x equal to 4 and y square equal to x and x axis. This is x axis. Clear? Curve y square equal to x. Y square equals to x, you know. Y square equals to x. Parabola. This type of parabola, y square equal to 4x, you know from 11th class. Y square equals to 4x. This type of parabola also y square equals to minus 4ax and x square equals to 4ay and x square equals to minus 4ay. What? This is right handed, this is left handed, this is upward, this is downward. These are the parabola diagram. So here diagram is what? Like this, parabola. Y square equals to x, y square equals to x. This is parabola. Okay. Now x equals to 1, x equals to 4, and x axis. This is x axis. This is x axis. This is x axis. Clear? So suppose x equals to 1 is here. So this is line x equals to 1. X equals to 1. And this is line x equals to what? 4. Line x equals to 1. Line x equals to 4. And this is curve y equals to x. And this is x axis. X axis means y equals to 0. Here y equals to 0 means x axis. So this, and this. Clear? So here curve is also here. And we know this curve is symmetric about x axis, that is this and this part are same. So we can find, because x axis, this is curve, this is line, this is line, this is line, this is line, this is curve. So this total is our required area. But for finding this area, we can find only area of this portion and multiplied by 2. Because 2 times, then this will be 2 times. So our required area is, we can name it A, B, C, D, E, F. Required area is equals to what? Area of AEFB, CD, A. Just we write like this. This, and this. This is our required area, both portion. Is equals to 2 times of area of what? This. A, B, C, D. A, B, C, D, A. Clear? And area of this portion by taking vertical strip PQ. Suppose PQ is vertical strip. We can write vertical strip. So area under the curve. This. What? 2 times of A to B y dx. 2 times of A to B means what? X equal to 1 to 4. 1 to 4. Here y dx. Y is the value of y from curve. Y square equals to x. Y equals to plus minus root x. Plus root x is upper side. Minus root x is lower side. So from upper side, root x. Y square equals to x means y equals to plus minus root of x. So we can write like this. Now solve it to integration. Very simple. X to the power 1 by 2. So x to the power 1 by 2 plus 1 upon 1 by 2 plus 1 and limit from 1 to 4. So we can solve it 2 times of x to the power 3 by 2. X to the power 3 by 2 upon 3 by 2, 1 to 4. Now solve it. 3 by 2, so 2 by 3. So just solve it. Here, this is equals to what? 2 times of x to the 2 by 4 by 3, 4 by 3, and first value x to the power 3 by 2 means 4 to the power 3 by 2 minus 1 to the power 3 by 2. Clear? Equals to 4 by 3, 4 to the power 3 by 2. 4 to the power 3 by 2 means what? Minus of 1. That is what? 4 by 3, 4 to the power 3 by 2 means 4, 2 square, 2 to the power 3 by 2, 2 to the power 3 by 3 minus 1. This means 4 into 7 by 3. So 28 by 3. 28 by 3. Okay. So answer is now in these questions in first quadrant. So we have to take only this part. That's why there will be no 2. 2 times means whole area. If we take first quadrant, in first quadrant, just we find whole area. But if we find in first quadrant, then half of this. So for these questions, this is also right, this is area of full portion. But area in first quadrant if you find, then only this part, that is half of this. Okay. So for these questions, required area is equals to what? Not 2 times, only 28 by 3 into half equals to 14 by 3. This is answer for this question. Okay. If we find total, then 2 times 28 by 3. Okay, 14 by 3 is the answer for these questions in first quadrant. Half of this. Okay. So this was the solution of question 1. So very simple. Area finding is very simple. Just you have to put the formula and identify the limit of integration, definite integration, and value of y, and then you can solve integral, get area. Suppose we take questions 2. Find the area of the region bounded by the y square equals to 9x, x equal to 2, x equal to 4, and x axis. What? Y square equals to 9x, x equals to 2, x equals to 4, and x axis. X axis means what? Y equals to 0. These are boundaries of our area. Okay, so we have to draw diagram. Y square equals to 9x. Find the area of the bounded region bounded by the y square equal to 9x, x equal to 2, x equal to 4, and x axis in the first quadrant. Here also first quadrant. So simple, just like this. Y square equal to 9x means just like same diagram, like this. Okay, this is x, x dash, y, y dash, origin, y square equals to 9x. Okay, x equal to 2. Suppose this is x equals to 2, this is x equals to 2, this is x equals to 4, this is x equals to 4. Clear? And x axis, that is this, y equals to 0, x axis. And this is first quadrant, also first quadrant, in first quadrant. So this part only. So this is very simple, just like same questions as first PQ. Okay. So required area, we have to write, consider according to question, consider on the following diagram. According to questions, consider on the following diagram. If you draw a diagram, then you can write only short in this line, like, and then required area. Therefore, required area is given by area equals to what area we required? A, B, C, D. This. So area of A, B, C, D, A is equals to, this is what? Vertical. Area under the curve between x-axis and curve and ordinates to ordinates. So y dx. From what? A to B. A to B means what? 2 to 4. Y means, y comes from here. This implies what? Y equals to plus minus 3 root x. 3 root x. So 3 root x upper part plus sign. So this dx, just you solve it only. Here 3 x to the power 1 by 2. So x to the power 3 by 2 upon 3 by 2. Limit from 2 to 4. So 3 cancel. 2 is here. X to the power 3 by 2. Limit 2 to 4. So what? 2. 4 to the power 3 by 2. Minus 2 to the power 3 by 2. Just we are getting like this. Now you can solve it. We can solve it. What? Equals to 2. 4 power 3 by 2. 2 power 2 power 1 by 2. So 2 power 3. 2 power 3 minus 2 power 3 by 2. This 2. 8 minus 2 power 3 by 2. 16 minus 2 power 3 by 2 plus 1. 5 by 2. 2 power 5 by 2. Okay. So answer is what? 8.1. 16 minus 4 root 2. 16 minus 4 root 2. You can write like this. Also 16 minus 4 root 2 or not. 16 minus 5 by 2 means what? 2 to the power 2 plus half. That is what? 16 minus 2 power 2 into 2 power 1 by 2 means what? 16 minus 4 root 2. This is our answer. So very simple. Okay. Now take question third. Take question third. Also. Okay. Question third is what? Find the area of the region bounded by x square equals to 4y, y2, y4 and y axis in the first quadrant. It is very similar questions to first. It is horizontally oriented. Okay. So horizontal formula we know here in first quadrant. So draw the diagram. Question third. Here question third. Take question third. Y is x square equals to 4y. We know the diagram. How can we draw the diagram? X dash. This is x. This is y. This is y dash origin. This just like this type of diagram. This x square equals to what are given? X square equals to 4y. X square equals to 4y. This is curve, parabola, upward parabola, this, and line is y equals to 2, 4 and y axis. Suppose this is y equals to 2, y equals to 2, and this is y equals to 4, 2 to 4, clear? And y axis, this is y axis, that is x equals to 0. We write x equals to 0 for this line, this is y axis, this is curve. Means x square equals to 4y and y equal to 2 to y equal to 4. This is horizontally. That's why we are using horizontal strip. Horizontal strip. PQ. Clear? This is our part. First quadrant. First quadrant is in this part. Only this part. Okay? So this part. A, B, C, D. So record area is given by area of A, B, C, D, A is equals to what? First quadrant. So single times, or this is horizontally. So x dy, x dy, and c to d. That is limit of y 2 to 4, 2 to 4, 2 to 4, 2 to 4, and x, value of x in terms of y from curve, value of x in terms of y. So x equals to what? Plus minus 2 root y. So you can get 2 root y because this is positive side, so positive value dy. Now solve it. 2 to 4, y to the power 1 by 2 dy, that is what? 2 times of y to the power 3 by 2 upon 3 by 2 integration limit 2 to 4. Now we can solve it. 3 by 2, 3 by 2. So 2 to 4 by 3 and y to the power 3 by 2, that is 4 to the power 3 by 2 minus 2 to the power 3 by 2. This is equals to 4 by 3. You can solve it. Square cancel 2 to the power 3 minus this 2 to the power 3 by 2. Okay. So find the value equals to 4 by 3, 8 minus 2 to the power 3 by 2 means 2 to the power 1 plus half, like this. 4 by 3, 8 minus 2 root 2. So we can write formula like this. Answer 32 minus 8 root 2 by 3. So we can simplify it and see what is the result. Okay. So 32 upon 3 minus 16 by 3 root 2. 8 by root 3. Just multiply. So 32 minus 8 root 2 by 3. This is the answer. Okay. 32 minus 8 root 2 by 3. Now take question 4. Find the area of the region bounded by the ellipse. X square by x square by 16 plus y square by 9 equals to 1. You know ellipse. How can we solve ellipse? Find area of ellipse. Ellipse is closed diagram. So you have to draw. First of all, you have to draw the diagram for the ellipse. Here ellipse, the given ellipse is what? Given ellipse x square by 16 plus y square by 9 equals to 1. This is the ellipse. Okay. So area of the region bounded by this ellipse. So we will draw like this. Ellipse, we know this ellipse is like this because A is greater value. So this is length is A square, A0, that is 40. X axis, Y axis, and X dash, Y dash is origin. This is ellipse. Okay. A, B, C, O. Okay. We have to find complete region, area of complete region. Because region bounded by the ellipse, this. That is complete area. So we know that you have to write. We know that ellipse is symmetric about both axes. Symmetric means same. These four portions are same. Symmetric means along about x-axis means above x-axis and below x-axis are same. Similarly, left hand side on the y-axis and right hand side on the y-axis are same portion. So ellipse is symmetric about both axes. Therefore, the required area, that means total area is equals to 4 times of single area. So for this single area, we can draw what? Vertical steps. It is P2 Q. Suppose. You have to write, since ellipse is symmetric about both axes. So area OABCO, you can write like this, OABCO is equals to 4 times of area of region bounded by BDD bounded, area of region bounded by ellipse is equals to 4 times of area of OABCO region. Clear? This is equals to 4 times of area of this region is given by what? Integration y dx. Integration y dx. And x from here x equals to 0, here x equals to 4. So 0 to 4. Now we can solve this integral and you can get the result. 4 times of integration 0 to 4 y from ellipse, from here, the value of y. So implies y square by 9 equals to 1 minus x square by 16, implies y square equals to 9, 1 minus x square by 16. So y equals to plus minus 3 root over 1 minus x square by 16. This is the value of y, plus and minus 3 root of 1 minus x square by 16. So here upper part, the value of y, upper part, so positive value, so 3 root over 1 minus x square by 16 dx. Now we have to solve this integral only. So this is equals to what? 12 0 to 4 root over 16 minus x square dx, taking LCM 16 and taking outside 4 by 4. Okay, because 16 here and 16 means taken outside of the root, then 4. So 3 into 4 by 4, that is 3 of 0 to 4 root over 4 square minus x square dx. And we know the formula for this integral, root over a square minus x square. So we can put the value of integral by direct formula. What will be the formula? This is equals to 3 a square minus root over a square minus x square. What is the formula? Integration of root over a square minus x square dx equals to what? X by 2 root over a square minus x square plus a square by 2 sin inverse x by a. This is formula. This is formula. Root over a square minus x square, x by 2 root a square minus x square plus a square by 2 sin inverse x by a. So here a means 4. So x by 2 root over a square means 16 minus x square plus a square means 4 square 16 by 2 sin inverse x by sin inverse x by a. X by a means 4. This. Now we have to put the value limit 0 to 4. Okay. Now solve it. We have to solve only integration, definite integral, very simple. We can put limit here 4 in place of x. So if 16 minus 4 square, 16 minus 16, 0. So the first part is 0 plus 16 by 2 means 8. Sin inverse 4 by 4 means sin inverse 1 means 9. Sin inverse 1 means 90 means pi by 2. This is first part minus x equals to 0. Here 0, this is total 0. 0 plus sin inverse x means 0, total 0. So this is equals to 3 into what? 3 into this is 0, 8. 3 into 8 sin inverse 1. So 24 pi by 2 equals to 12 pi. This is our answer. Into, because sin inverse 1 means pi by 2. So 12 pi is the answer. So what we see that first of all you have to identify the diagram, the area of the region, and area is bounded by in what type of diagram? For we can take horizontal and vertical strip. Vertical strip means y dx, area under the curve, x-axis. So use the formula and put value from equation of curve for y, and then put limit and solve integral, definite integral. Then you can get the area. This is 12 pi for this question. Okay. Question 4, 12 pi. Okay. So very easy. For this you have to draw diagram, ellipse, parabola, circle, line. So do some questions, then you can do very easily. Okay. Now questions for your attendance. So today only 3 questions you have to solve and reply to me for your attendance. Okay. 3 questions that are what? Question 5, 6 and 7 of exercise 8.1. Question 5, question 6, question 7. So 5 is just I will give hint for this. Question 5. Find the area of the region bounded by the ellipse. Here equation of ellipse is x square by question 5. Question 5. Question for your attendance. Okay, question 5. X square by 4 plus y square by 9 equals to 1. This is ellipse. Okay. So find the area of the region bounded by this ellipse. Same questions as 4. So you have to do what? This type of, here a is less value. So ellipse is like this. Okay. Like this. Okay, ellipse will be like this. Just you have to find the area of this ellipse. Okay, so here 4 means a square means 2 square means minus 2 2 plus 2. Here 3 means plus 3 and minus 3. Minus 3 x value and value of x is 0. Here 0 minus 3 and here 0 3. Here 2 0 and minus 2 0. This is, so finding area, we have to find this. We can do by any method. You can take horizontal vertical strip, also horizontal strip. If we take this strip PQ, then our area will be what? 4 times. Also this ellipse is symmetrical about both axes. So 4 times of what? Y dx. Y dx from here to here. 0 to 2. 0 to 2. We can solve. 4 times of y. Y is from this y. Y equals to what? Y equals to, also 9 means Here 9 plus minus 3 root over 1 minus x square by 4. By taking plus sign, we can get 4 into area equals 4 into 3 root over 1 minus x square by 4 dx. Thus you have to solve it. Question 5. Okay, very simple hint. Question is simple. Okay, so you have to do it. 5. Now question 6. Question 6. For question 6, see what is the question here. Find the area of the region in first quadrant enclosed by the x-axis lying x equal to root 3y and the circle x equal to 4y. Here we are given x square plus y square equals to 4. This is circle. Line is what? Line is x equal to root 3y. X equals to root 3y. This is line. And also circle x equal to y equal to 4 and x-axis in first quadrant. X-axis. This is our boundary of the region. So we know this is equation of circle having center, origin, radius 2. So we can draw like this diagram. Radius is 2. So 2 by taking 2, radius this is 2. This is 2. 2 0. This is 2 0. Okay, origin 2 0 and line x equal to root 3y. So line will be here like this. Okay, not y equals to x. X equal to root 3y, some formula, this part. Okay, so x in first quadrant, and here also x-axis. This is x-axis. Y equals to 0. X-axis. This is x-axis, and this is line. What? X equal to root 3y. This is curve. What? X square plus y square equals to 4. This curve. So this is our part. Okay. For finding area of this part, you have to divide this region in two parts by its intersection point like this, drawing perpendicular line. Okay, so this part is distributed in two part area. So area, question 6, required area equals to what? First part A1, second part A2. A1 plus A2. Integral plus integral. You have to do 2 times. Here, taking vertical strip, you can do, or you can also easily find by using simple trigonometric, a simple formula of area, half base into height. This is base, this is height for this triangle. And also you can do by integration. Okay. So, upper curve ydx, also ydx for first part, second part, for this part, and also here is this pq, this p dash q dash, and here what will be the value? Here you have to find, solve line and curve, this and this, you have to solve it, and you can get here result. Clear? X equal to this, so 3y square. Here 3y square equals to 3y square plus y square, 4y square. So 4y square equals to 4 cancel, y square equals to 1 is plus minus 1. Value of y is plus minus 1. If value of y is 1, then we can solve and x equal to root 3. So this is root 3 1. This is root 3 1. So limit will be what? For this part, from here to here, root 3, 0 to root 3, and from here to here, root 3 to 2. This is given. So 0 to root 3 and root 3 to 2. You have to solve y from this part, this part. That is what? X by root 3. And here y from this part, this y equals to what? Plus minus root of 4 minus x square. So root of 4 minus x square. You have to solve this and this integral, both integral. You can get the result. Clear? This is the hint for question 6. Now, another questions, you have to solve 3 questions only, 5, 6 and 7 for your attendance. Okay, so solve and Send to me. Question 7. 7 is what? Find the area of the ellipse, smaller part of the circle x square plus y square equal to a square cut off by the line x equal to a by root 2. X equals to a by root 2. This is line, and x square plus y square equals to circle a square. This is circle, this is line. Cut off part, smaller part. So circle is this. Suppose this is circle of a radius. This is circle of radius what? A. 0, a radius. That means a0. This is a0. Clear? a0. This is radius. Okay. Now x equals to a by 2 is the line. Suppose x equals to a by 2. This line is x equals to a by root 2. If this line is x equal to a by root 2, that means smaller part is what? This part, not this. This big larger part, this is a smaller part. So we have to find area of this part. Since circle is symmetric about x-axis, so this part can be found by 2 times of only this part. And for finding this part, take vertical strip P to Q, and from limit in this part we have to apply formula. What? Y dx. And limit of x from here to here. That is upper part a, and lower part is what? X equals to a by root 2. A by root 2. So this is our required result. Y comes from circle. So y equals to what? Plus minus root over a square minus x square plus. So 2 of a by root 2 to a root over a square minus x square dx. Okay, so this gives result. You can use direct formula. You can get the area. So 5, 6, 7 are very, very important questions also. So you have to do it. This was the question. What? 7, 5, 6, 7. So solve it and send to me for your attendance. Okay.